We are executing a precise analysis of AI-powered enterprise resource planning systems and the human blueprint required to sustain them. This is an executive briefing. We are stripping away vendor marketing collateral to examine why massive system overhauls routinely fail, and more importantly, the structural and human frameworks required to actually survive the transition.
$580 million. That is the financial crater left behind by the German grocery chain Lidl in 2011. They spent 7 years attempting to modernize their inventory system using SAP, only to abandon the entire initiative and revert to their legacy infrastructure. The core lesson here is not about a specific software vendor failing to deliver. It is about the fundamental impossibility of forcing deeply entrenched, unique business processes into a rigid, predetermined digital framework. When organizations ignore the friction between how work actually gets done and how a system demands it be done, the result is catastrophic capital destruction.
Our agenda for this briefing is structured into 4 distinct phases. We begin with the high-stakes executive overview, examining historical implementation failures. We move to a detailed operational postmortem. Then we dissect the human blueprint. Finally, we establish a chronological action plan with strict guardrails. Part 1. High-stakes hook and executive overview. The cost of illusion. $100 million in unprocessed orders. That was the operational reality for Hershey in the fall of 1999. Driven by internal panic over the Millennium Bug, corporate leadership mandated the simultaneous, rushed replacement of their entire enterprise environment. They attempted to push a massive ERP, a supply chain module, and a customer relationship management system live all at once, directly ahead of their peak holiday retail season. The result was a total collapse of integration. The data simply refused to flow across the architecture. Warehouses were full of product, but the system could not process the orders to ship them, leading to a massive, self-inflicted blow to their market share and a permanent case study in executive recklessness.
Analyzing the wreckage of deployments from Hershey to Nike reveals a definitive, recurring pattern. These events are rarely technical glitches. They are profound failures of executive discipline. Projects routinely capsize under the weight of scope creep, where leadership loses sight of the minimum viable implementation required to simply keep the business running. They suffer from inadequate resourcing, rushed testing schedules designed to appease boardroom timelines rather than system readiness, and fundamentally flawed data migration strategies. Trying to accelerate past baseline stability creates catastrophic operational disruptions. If you attempt to layer advanced artificial intelligence models over dirty, unstructured, or siloed data, the system will not magically clean your enterprise. It will simply help your organization execute the wrong decisions at a vastly accelerated pace.
Part 2. Detailed operational postmortem. Process before platform.
The architectural shift we are targeting moves an enterprise from a state of inefficient, reactive processing to one of proactive, enhanced decision-making. Integrating artificial intelligence into a core ERP architecture relies entirely on 3 foundational pillars: predictive analytics, real-time data analysis, and automated workflows. But the technical reality is unapologetic. The sophistication of your algorithmic layer is entirely dependent on the integrity of your foundational data. If your baseline inventory ledgers are inaccurate, or if your financial data is compromised, your AI layers will confidently synthesize that chaos and present you with precise, highly optimized, and entirely incorrect strategic guidance. Process must always precede the platform. This introduces a massive structural paradigm shift that leadership must fully comprehend. Traditional enterprise resource planning systems are strictly deterministic. You input a specific variable, and you receive the exact same output every single time. It provides a baseline of operational safety and predictability. Artificial intelligence, conversely, is inherently probabilistic. These models generate highly educated outputs based on massive, shifting data sets, which means the responses are subject to data drift and will evolve over time. Transitioning a workforce from an environment of absolute binary certainty to an environment governed by highly probable statistical outcomes creates intense organizational friction. Your execution strategy must account for this shift in structural reality.
Selecting the correct platform requires an objective understanding of vendor architectures, stripping away the marketing collateral. SAP S/4HANA remains the dominant heavyweight for complex manufacturing and supply chain environments. Oracle Cloud ERP commands environments heavily weighted towards complex finance and strict regulatory governance. Microsoft Dynamics 365 provides the most agile architecture for organizations prioritizing workflow flexibility and rapid integration. It is critical to understand that specialized AI layers do not replace these core transactional engines. They sit strategically on top of them, designed to ingest the core data and solve specific reporting bottlenecks without compromising the underlying system of record.
Before any advanced optimization or AI layer is activated, you must secure baseline core integrity. This mandates 3 rigid, non-negotiable stages of testing. First is the conference room pilot, designed to validate basic system alignment with your core business processes. Second is systems integration testing, which aggressively evaluates the cross-departmental handoffs and data flows. Third is user acceptance testing, acting as your definitive operational dress rehearsal. Compromising on any of these 3 stages to meet an arbitrary deployment date is the exact executive miscalculation that triggered the historical failures we examined earlier.
Part 3. The Human Blueprint, Identity Capital, and Change Fatigue.
Consider this fundamental truth of digital transformation. The technology rarely fails. People, processes, and incentives do. Close to 80% of enterprise AI initiatives never reach production scale. They die in the pilot phase. This massive failure rate is not a symptom of flawed algorithms or inadequate computing power. It is the direct result of a structural inability to absorb change. Organizations consistently fail to align their internal incentive structures and their human capital with the technical realities of the new architecture.
The capital allocation data from top-performing global enterprises exposes a stark contrast in strategy. The top quintile of AI leaders completely invert the standard investment ratio. They allocate 70% of their transformation budget directly to people and processes, reserving only 30% for the actual algorithms and software tooling. The organizations that fail do the exact opposite. They exhaust their capital on expensive vendor licenses and technical integration, completely starving their organizational readiness and change management frameworks. That single capital allocation decision is often the dividing line between a successful enterprise evolution and a massive sunk cost.
User resistance is deeply rational. It is driven by 5 distinct psychological forces that must be managed. The first is identity threat, which we will explore deeply in a moment. Second is the perceived loss of autonomy. Third is the issue of algorithmic fairness, where users fear the system may amplify hidden organizational biases. Fourth is the sheer lack of system trust. And fifth is incentive alignment. If you radically alter how an employee is required to work, but you continue to measure and compensate them based on a legacy scorecard, you are structurally guaranteeing resistance.
Identity threat is the most critical failure point in any AI rollout. Traditional software implementations simply automated manual, repetitive tasks. Artificial intelligence, however, begins to replicate complex human judgment. This creates an existential crisis for knowledge workers. Imagine a senior analyst who has spent 2 decades cultivating specific professional expertise. When an algorithm demonstrates the ability to execute their exact analytical function, that employee does not perceive a helpful operational tool. They perceive a direct replacement of their identity and career capital. To mitigate this, leadership must actively pivot these senior staff members from passive end users into authoritative trainers of the AI models, integrating their expertise into the governance loop rather than discarding it.
Part 4. Chronological Action Plan and Guardrails, the Execution Mandate.
We now move to the rigid execution frameworks required to manage this transition. You must never commit to a multi-year AI transformation without first executing a strict 90-day diagnostic. Month 1 is dedicated to mapping your human geography, identifying the exact individuals and teams who hold the informal power to either champion or sabotage the rollout. Month 2 focuses on aggressively stress testing your existing operating model against the proposed AI use cases to surface baseline data gaps. Month 3 is required to build out the granular change roadmap and secure the necessary budget allocations. Attempting to bypass this diagnostic phase to accelerate deployment will inevitably cost you 18 months of operational gridlock later. Following the diagnostic, the enterprise enters the strict 12-month implementation arc. Months 4 through 6 are dedicated entirely to building the technical and organizational foundation. This means securing data structures and establishing strict governance. Months 7 through 9 initiate the deployment in controlled sequential waves. Months 10 through 12 focus on scaling the capability and institutionalizing the new behaviors. Executive leadership must understand that building this change capability and managing this arc for a mid-size enterprise requires a dedicated budget allocation of $1 to $2 million, which is entirely separate from the software licensing and technical integration costs.
Bypassing identity threat and rebuilding organizational trust requires highly specific behavioral interventions. You must implement peer-driven learning frameworks, bypassing the traditional top-down management directives. Executive leadership must engage in visible, public failure rituals, demonstrating that making initial operational errors with the new AI tools is an expected part of the learning curve. You must conduct regular friction audits to identify where the system is failing the users. Finally, you must establish strict dead zone protection. This means temporarily exempting your most critical revenue-generating teams from the initial rollout waves, ensuring that daily business operations do not collapse while the broader organization adapts to the new architecture.
When reporting the progress of an AI-powered ERP implementation to the boardroom, you must ruthlessly eliminate vanity metrics. Simple login counts and software utilization rates are meaningless. The only metrics that command executive attention are deep operational indicators. You track adoption depth, which measures the actual percentage of complex workflows completed end-to-end using the new AI capabilities. You measure time to first value. You track the voluntary advocacy rate among key personnel. You monitor the operating model fit score to ensure the technology aligns with business reality. Ultimately, net value realized is the singular metric that justifies the capital expenditure.
The integration of enterprise artificial intelligence forces a definitive structural choice on senior leadership. You must secure your foundational data, standardize your core processes, and invest disproportionately in your human capital. Any strategy that attempts to bypass these difficult realities is nothing more than installing incredibly expensive software over fundamentally broken operational workflows. I will leave you with this directive to consider. Are you engineering an enterprise architecture capable of continuous, compounding AI adaptation? Or are you simply installing software?